Welcome back to the course Corrosion Protection Methods. We are going to start lecture 40, and today we are starting a new topic which is based on coatings and associated corrosion protection. Now, if we look around us, we will see that coatings are everywhere, almost everywhere. Now, let's start with our households. If we see kitchenwares, those are coated. If we see our grills, window grills, those are coated. Okay. Now, if we see ACs, air conditions, if we see fans, almost everything is coated. Now, some of the cases those coatings are done not to protect the material from corrosion. For example, if we talk about coatings on beds, okay, wooden beds or wooden chairs or something like that. So, those time we put a coating on top of it, which is a paint. Now, that paint is given just to protect those wood from getting attacked by termite. Fine. So, but some of the cases, for example, kitchenware, let's say grill, we paint. The primary the purpose is to protect it from getting degraded or protect it from corrosion, because they will form rusting. So, that rust avoidance we need to put coating. Now, there is one more purpose for that coating. So, sometimes we have to also improve the aesthetics. It should look good. Okay. So, that is a purpose which is which sometimes becomes the primary reason, but it's actually the protection of that grill material or fan material from getting corroded. Now, if we go out and then look at other substances, for example, automobile, starting from mobike, from cycle, bicycle to cars, to buses, to trains, everywhere we put coatings. Now, come to transports, for example, concrete. In the concrete, we use rebars. Some of the rebars are coated, like epoxy coated rebars are available. So, those coating actually protects the material, protects the rebar before it gets installed in the concrete. That means, let us say one set of rebar is actually getting transported from one end to another end. That time, if we have some sort of coating, then definitely it will not corrode during the transport. Fine. At the same time, when we put that epoxy coated rebar, there would be definitely flaws. Those flaws are called holidays, and we will talk about that holiday. So, those are some of the breaks in the coating, and that break point where material is getting exposed to the concrete. Okay. So, those are the point of severe attack. But if we use cathodic protection like sacrificial anode or impressed current cathodic protection, that time the total current requirement goes down, because as we have seen earlier cases in case of inhibitors, we have seen that if we use in case of earlier cases, for example, in case of cathodic protection using sacrificial anode, we have seen that in case of bare pipe, we need higher current or higher current output from the sacrificial anode, and if we use coated pipe, that time we need a less current output from the anode. So, the current output or the current requirement to protect that particular material, if it is coated rebar, reduces to a great extent. So, there we also find coating. Now, if we talk about railroads, fine, there also people do use coating, because the varnish, for example, if we consider fish plates, in the fish plates region, we do experience one particular type of corrosion process where wear is also involved, that is called fretting corrosion near the fish plate, where you have two plates which are fixing two joints, two rails which are getting joined. That means, those are basically held together by the fish plate. So, there we can experience fretting attack. So, if we put a lot of grease material over there, that actually acts as a coating, because that avoids contact, or that prevents moisture or oxygen to get in touch with the metal or the steel. This is one part. Another thing is that grease material also reduces the coefficient of friction. So if friction reduces, so that means the wear tendency will reduce. So here that coating is actually serving two purposes. One is it reduces the coefficient of friction. At the same time, it provides a kind of barrier to the environmental corrosive agents like oxygen, H2O. Now, if you come to aerospace, we have coated structures. For example, if we talk about turbine blades, where we do use thermal barrier coatings like yttria stabilized zirconia, fine. So that particular coating helps preventing high temperature oxidation or high temperature corrosion of the turbine blades. Now we can also use stellite coating. Okay, for example, in case of internal combustion engine, we do use stellite coating. So stellite coating is nothing but the cobalt based alloys, okay, where we can also add a little bit of tungsten or molybdenum to improve its wear resistance. Now stellite coating can also be used when we use a hard facing. Now the purpose of the coating there mainly to serve wear resistance, a very high wear resistance, but stellite coating also provides a very good corrosion resistance. Now you see many of those examples what we are seeing, coating doesn't only provide one particular purpose, it is used for multi-purpose applications. For example, one such example, let's say zinc coating on iron. Okay, if we put zinc coating, it looks a bright white color, fine, that gives you a kind of aesthetic, but zinc coating provides one particular advantage is it doesn't expose the steel to the environment. Now if by chance there is some points where there is a scratch, so the underlying steel surface is exposed. Now since it's a zinc coating, galvanization is mainly zinc coating, that zinc acts as a sacrificial anode to the underlying steel. So zinc would dissolve, and the portion of the steel which is exposed to the environment, that particular segment will act as cathode and it will get protected due to a cathodic protection, fine, provided by the sacrificial nature of zinc. So that means it has two advantages. One is of course it is acting like a barrier, and at the same time it is also giving sacrificial protection, fine. Now if we talk about let us say a nickel coating, fine. Nickel coating is basically nickel coating or let us say a steel. So now that nickel coating will be acting as a cathodic to the underlying steel surface. But if we put nickel, and on top of nickel you can also use chrome coating, so that will give you a very excellent corrosion resistance, provided that particular surface doesn't get peeled off or doesn't get scratched off. So if the underlying steel is exposed to the environment, then those are called cathodic coatings, because that particular coating material is cathodic compared to steel in that environmental conditions. So that case only purpose is, that particular coating purpose is, it gives you a barrier protection, because it doesn't allow the environmental species like water, oxygen to get in touch with steel. It will not provide you sacrificial effect. Copper coating on steel, for example, some of the electrodes, for example, when we talk about welding, sometimes that coated material, that particular steel material is coated with copper. Okay, so that coated steel electrodes are used. So this copper also gives you a protection around it, and the purpose is different, but it is coated. It also protected from corrosion, provided it doesn't get exposed. So the purpose of copper coated steel, this is not part of our discussion, but people do use copper coated steel rod or steel wire for welding. So that means we could see that coating has different purpose, but Our discussion will concentrate on the corrosion protection part of it. So, if we talk about the purpose of discussion or the scope of discussion for our case, okay, this is mainly, first is it should cover up metal surface and provide a barrier to environment. This environment could be gaseous environment, this environment could be electrolyte, liquid, aqueous environment, this environment could be chemical environment, some toxic chemical environment. So, this barrier to the environment, and while providing the barrier, so that means it does not allow those chemicals or environment to get in contact with the metal surface. So, this gives you a very good corrosion resistance. Fine. Now, when we talk about barrier, this barrier can serve different way. For example, it can provide excellent resistance to diffusion of species. Like chlorine ion, okay, or hydrogen, right. If it provides resistance to corrosive agent, definitely. So, these particular agent, for example, Cl minus, it may not participate in the electrochemical process, but it can actually break the passive layer on the metal surface. So, it can act negative to the passivity of the metal surface. So, that way it can expose the metal surface and continuous dissolution can happen. Hydrogen can lead to hydrogen embrittlement. Hydrogen embrittlement it can provide. So, if we stop diffusion of hydrogen by putting a barrier, then definitely it can, that particular material will be safe from hydrogen embrittlement, and this is actually lead to, this hydrogen embrittlement can lead to a catastrophic failure. This is one. It can also resist, or it can also act as a passivating agent. Sometimes the paints are actually impregnated with uh, inhibitors which can actually passivate the surface. So, when one can make the surface passive, as we have seen in case of while discussing inhibitor, it can actually give, it can actually provide good amount of corrosion resistance. Now, this can also provide resistance to charge flow. Okay. So, now this coating, for example, if you have a, this is the metal surface and this is the coating what you are using, let us say this is my coating region. So, this coating can act as a capacitor and then provide a kind of, and also it will also provide resistance, a resistance path R to the charge flow. Okay. So, this resistance, if it is providing very high resistance, definitely it will give a very good corrosion protection. Now, consider some ceramic coating, that ceramic provides good amount of resistance to the flow of either positive charge or negative charge, because there the flow of charge happens by, there are two segments, one is p type or n type, one is through the flow of electron or the positive charges. So, if we have resistance to the charge flow, definitely it will increase the corrosion resistance. Fine. Now, when we talk about a barrier, it can also provide some sort of added advantage like erosion protection, erosion corrosion resistance. Let us say that the coating is very hard. So, hard means hard coating, definitely the erosion resistance go up because it will increase wear resistance. But at the same time that coating can also provide good amount of corrosion resistance. So, it again serves two purposes. Now, when we talk about hard surface, it can also give a good amount of cavitation resistance. Okay. So, that cavitation resistance also improves because of that hard surface. Why cavitation corrosion happens or cavitation erosion happens? Because you have a collapse of bubble due to the pressure difference, and that bubble collapse can lead to a shock waves to the metal surface, and that shock wave can have a deformation, and those deformation zone can get extra bit of corrosion because we know that whenever the metal surface is getting deformed, dislocations are created, and those dislocation creation can lead to increased activation of that particular segment. So, that will act like a local anode and it will dissolve. So, if we have a hard surface, if the resistance to the shock wave that can be improved, definitely it will improve cavitation resistance, and cavitation falls under erosion corrosion field. So, this is one such possibility. That means it provides both the effects, wear resistance as well as corrosion resistance. Now, come to some other segments, like if we talk about watches. Okay. So, the watches, they are sometimes gold coated. Okay. It actually improves the corrosion resistance, but at the same time it actually improves the aesthetic. So, that means look good. Okay. So, that is another purpose of gold coating. So, now when we talk about watches, we actually wear them, and when we have sweat, the sweat contains a lot of salt. So, that means that salt containing solution can have a huge corrosion tendencies. So, if we have gold coating, definitely it can resist that corrosion, huge corrosive ability of that particular sweat solution. Right. So, these are I have just pointed some of the aspects that what it does when it provides the barrier. Now, apart from barrier, it can also serve as a sacrificial effect. Okay. So, this falls under anodic coating. We will talk about that. Sometimes we do use coating and then we go for cathodic protection. And this cathodic protection could be either ICCP, which is impressed current cathodic protection, or sacrificial. Now, if we have coating on that material, let us say pipeline, then the total current requirement for the protection will be decided by the breaks that are there in the coating. If we let us say this is a pipeline, on top of it we have a coating, fine. So, this is a kind of a break which is called holiday, fine. So, this now question is how to protect this segment. For that we have to send current, as we know that when current enters to the metal surface through the electrolyte, that segment is getting protected. So, here current enters. So, the total current requirement will be very low and the sacrificial anode will operate for a longer duration or if you want to use ICCP, the total current requirement would be very low, but still the material would get protected from the corrosion abilities of the surrounding atmosphere where the pipe is placed. So, this is another purpose it can serve. Now, we can also have different other purpose, like let us say turbine blades. So, these turbine blades operate at a high temperature. So, that whenever we talk about high temperature, we have to handle gaseous environment. Gaseous environment. Now, during that particular environment, the major problem becomes oxidation, and the second part is hot corrosion, because when that fuel is getting burnt, there could be possibility of salt creation on salt deposition or salt environment there, high temperature salt. So, there this particular would lead to hot corrosion, and oxidation, definitely we are actually burning oxygen. So, that oxygen can lead to a serious oxidation on the surface. So, that time, and oxidation, we know that it is a corrosion process, because when we talk about oxidation, okay. So, now if we consider a metal surface, this is the oxide surface, oxide layer, and let us say this is oxygen. Now, for whether this is corrosion or not, for that we need to see whether there are 4 components that are needed for corrosion. What are those 4 components? One is cathode, where cathodic reaction happens, anode, where anodic reaction happens, then electrolyte, and the fourth one is conductor. In one of the circumstances, that oxygen, the metal would dissolve like this, let us say 2 electron, 2 plus, and this 2 electron would move through the other surface, which is oxide gas interface. So, there oxygen can take 2 electron and then form O2 minus. Now, this metal ion which is forming at this interface, that can diffuse out through the oxide layer and then connect with O2 minus, it can form MO, which is the oxide layer, or oxygen can, this particular species O2 minus, this can also diffuse in, and here M2 plus can react with O2 minus and then form MO. Now, you see this is my cathodic reaction. So, this becomes my cathode. Here we are having anodic reaction, this surface becomes my anode, and electron is flowing through the oxide. So, it becomes, oxide becomes conductor for the charge. At the same time, we are seeing that the metal ion is moving or diffusing through the oxide. So, that means oxide is also acting like an electrolyte. Okay. So, now you see we have all 4 components. So, this can also be considered as corrosion. So, if we prevent oxidation, we are actually preventing corrosion. So, turbine blade we use thermal barrier coating. So, these are mainly ceramic material, oxides like yttria stabilized zirconium. So, where we add around 8% of Y2O3 in ZrO2, it actually stabilizes the high temperature phase, and that is what you can get very good oxidation resistance, which are resistant to the turbine blade. And turbine blade, what are the materials? Generally nickel, aluminum alloys, they are made, nickel, aluminum, titanium, nickel, titanium, those are the alloys, costly alloys which are used for turbine blade making. So, that means if we have this particular coating, this turbine blade can operate at a higher temperature. Now, this is one such classical example that it can also provide barrier to the oxidizing agents, whether it is oxygen or moisture or CO2, it can provide a barrier. Okay. So, when it provides barrier, the functionality becomes multi ways that functionality can be served. Okay. For example, one case it can provide wear resistance, one case it can provide oxidation resistance, aqueous electrolyte corrosion resistance, or even chemical resistance. For example, we can have a glass coating or we can say cement coating. So, that time this glass coating, this is very important when we talk about using container for chemical processing equipment. Let us say very strong corrosive agents, corrosive gases, if you want to hold it, chemical reactor. So, there the outer surface definitely it's steel, made of steel, but the inner surface we coat with many times they are coated with glass. Okay. And glass has a very high corrosion resistance. It can prevent, it can act as a very good barrier to the environment. Now, question is when we use that. So, this glass is brittle, isn't it? So, when we have a brittle coating, there we should be careful that there is very little impact on that metal, on that particular coated surface. So, if it breaks, then it can go away in no time, because the corrosive effect of those chemicals would be very strong. So, the chemical reactor we make glass coated reactor, right. So, this is one such example that we make use of something with a purpose that it should provide very good corrosion resistance or chemical attack resistance, but at the same time we should also see that what are the conditions at which what are the condition for which this particular glass coating will be uh, will serve the purpose of protection. So, similarly cement coating also is brittle, but if we do not have any impact, then cement coating can work for a longer duration and it can give a very good corrosion resistance. Like that way, if you see that every time it gives you a barrier protection, but at the same time we have to also consider some other factors, okay, like it should have a quite good amount of strength, it should be impervious to some of the species going through the particular barrier layer onto the metal surface, and then at the same time it should provide good amount of resistance to charge flow, it should provide good amount of resistance to the diffusion of species. So, then it will act a fantastic barrier to corrosion protection. Now, so that means we could see that we have to also make sure that the coating or barrier, if it is active as a barrier, then it must serve some of the basic properties. What are those basic properties? Let us look into that basic properties. Now, when we talk about basic properties, it should have high degree of adhesion. That means, if we have a coating on a metal surface, that particular coating should have a good bonding with the metal surface. So, if the bonding is poor, then definitely it will peel off it will peel off, or it can get removed from the metal surface, a disjoint from the metal surface, then the purpose of coating is lost. So, it should have a very good bonding with the metal surface, and depending on the purpose or depending on the applicability we should use. For example, if we want to use some coating where a serious abrasion is possible, like let us say there we cannot use paint, or the paint can get removed quickly. So, there we have to use metallic coatings or ceramic coatings, I'm just giving one example. So if you have heard about deck plates, so deck plates are basically a huge metal plates on top of which we have movement of conveyor belt, and in the industrial scale conveyor belt they are used for carrying coal, carrying sinter material. Now those particular belt material, they are actually, it's basically getting supported by the that deck plates. Now deck plate region is very dirty because it's open in the environment. Now coals are falling, coal powders are falling on that, there is a lot of dust, as well as if it is a rainy season, lot of rain falls on that particular deck plates. Now if deck plate is to be protected from, and the corrosion as well as wear is very, both are very severe in case of deck plate. Now if we would like to protect that deck plate, the better way to protect is not by painting, by using some coating which will be resistance to wear as well as corrosion. The one of the better ways to protect is by putting some metallic coating which can serve both the purposes. Now, so that metallic coating should have a very good bonding with the steel surface, because deck plates are made of steels. Now, for that generally the technique that can be used is basically HBOF. There are techniques, HBOF, high velocity oxy-fuel coating, or APS, atmospheric spray coating, where that metal powders which are to be coated on the steel, those are forced and impinged on the metal surface at a high temperature. So that high temperature will fuse those metal particles and then those get attached to the metal surface. So we will show one such example. For example, if we talk about, then okay, fine. When we talk about adhesion, we should also talk about interface. Interface between metal substrate and coating. So that interface we should look at very critically so that adhesion is improved. Now we will talk about more on this particular property. Then we can think of another property. It should have high degree of compactness. So what does it mean? That means it should have very little porosity or no porosity or very little porosity. This porosity can actually take the electrolyte to the surface of the metal. Okay? So that means it is better to have no porosity. It should have quite a lot of strength, good strength, or we can talk about hardness. And if it is malleable, so that is better, okay? Or we can say a bit of ductility. Instead of malleable, we can use deformability. At times there could be a bending load onto the coating. So during that it should not get dislodged from the surface. So that's why good strength, hardness, I am just giving one example, hardness. It can be in terms of high degree of, high level of tensile strength, that is also very effective, as well as if it has a good fairly fair amount of deformability. So it should not get broken during the bending loading. Okay. So this is a good strength. Then definitely it should have a very high degree of resistance to diffusing species. For example, hydrogen or chlorine ion, we will have example for that. Fine. Now third part is it must cover up surface completely as well as uniformly. Now if we have a surface like this, if the coating surface is wavy like this, that is not good. Because whenever you have a wavy pattern, let us say it is sitting with another, it is attached to another plane, this particular segment are vulnerable for breakage. Okay? That is not good. At the same time, if you have a coating surface, if the coating is like this, some region it is thin, some region it is thick, then this region, if there is every chance that this region can have a kind of a break or removal of that coating, and then this surface is exposed. So, that means it should cover up completely, and at the same time it should be uniform thickness. And that thickness, when you talk about uniformity, it should be fairly thick. Okay. At the same time, it should not be thick. If see, this thickness of this coating will be decided by the cost of the coating material as well as process. For example, if we talk about galvanization, that galvanization can be possible by doing dip in the zinc bath. You just dip the steel sheet metal, that will be coated. There could be another process, that sheet material or the particular part, if we have to have zinc coating, we can also go for electrodeposition. So, electrodeposition, generally the coating thickness will keep it at a lower end, but in case of other coating methods like HBUF or APS coating or atmospheric plasma spray, we go to a fairly thick coating. Okay. It is decided by what is the need of that coating, what is the purpose that coating has to serve, and what is the process that we follow. At the same time, cost of the coating material. Let us say gold coating on watches, that coating thickness hardly it goes to few angstrom, okay, maybe 0.1 or 0.2 micrometer at the most. Okay. So, that means gold is very costly. So, the gold purpose is to give a protection. Okay. At the same time, it gives a very good look, and it also gives you a kind of protection, means towards the protection against the sweat solution. Okay. So, this is cost and process that will decide, as well as the purpose. Those will decide the application of that thickness, application of the coating up to what thickness we want it. Fine. Now, coming to this interface, the interface we look at separately. If the interface is smooth, it's considered to be better, but if the interface is rough, there could be a possibility of pore formation along those interfaces. Now, you consider that pore formation happens, pore formation is taking place along the interface. If there is a kind of a thermal loading, the spore can actually expand and there could be a possibility of peel off. So, we have to look at interface separately. Now, coming to any other aspects like long life. So, that coating should give a very good protection for a longer duration. Long life, at the same time ease of repair. At the same time, when we talk about repair, it should come up with maintenance. Fine. It should provide long life, ease of repair. That means, if there is a breakage, we should be able to immediately recoat it. Okay. For example, if we talk about a dent or the scratch on the car. Okay. So, now that coating you can recoat it in a daytime. Okay. So, you do not have to wait for longer duration. Okay. So, that ease of repair, maintenance, long life, those are basic traits of having a better coatings. So, these are some of the aspects we should talk about. So, we will see that major purpose of the coating is to give protection to the steel from corrosion. Okay. And that corrosion could be either aqueous corrosion or chemical attack or high temperature oxidation or hot corrosion. Those things we will talk as we go ahead. Okay. So, let me stop here. We will continue our discussion on the coating in our subsequent lectures. Thank you.